Find the image of a function f of x equal to the absolute value of negative x squared plus 3, defined on the following domain. The domain is this one, from negative 2 up to 2. It means x varies between those variables, those numbers. Now, you need to circle the correct answer. We have 1, 2, 3, 4 choices. So write solution. You see, here you have the function f of x, which is equal to the absolute value of negative x squared plus 3. Also, we have the domain, which is negative 2, negative 1, 0, 1, and 2. So now, if the x in the function is equal to negative 2, means we have negative 2 in place of x of the function. So this negative 2 is going to replace x in the function we have here. So we have the absolute value of x squared. Now this x is becoming negative 2. So we have negative 2 here, then square plus 3. This one is equal to the absolute value of negative 2 square, which is 4. Then plus 3. This one is equal to the absolute value of negative 4 plus 3, which is equal to absolute value of negative 1, which is equal to 1. Right? We have also function f of x, where x of the function is equal to negative 1. Now this negative 1 is going to replace also x to have the absolute value of negative 1 square plus 3, which is equal to the absolute value of negative 1 plus 3, which is equal to the absolute value of plus 2, which is equal to, for x which is equal to 0, this one will be the absolute value of 0 square plus 3, which is equal to the absolute value of 0 plus 3, which is equal to the absolute value of 3. Now it is equal to 3. For x which is equal to 1, this is equal to the absolute value of 1 square plus 3, which is equal to negative 1 plus 3, which is equal to the absolute value of 2. Now it is equal to, right? I have also for f of x, now this x is going to be 2 as in the domain. Now it is absolute value of negative 2 square plus 3, which is equal to the absolute value of negative 4 plus 3. Now it is equal to the absolute value of negative 1, which is equal to 1. You see, those numbers we get here are the images. So they form the set of the range, and the range is normally the image. So the range or image will be the set of 1. This is 1, this is 2, this is 3, 2 again. We can't write 2 twice. We can't write 1 also twice. Now it is 1, 2, 3. This is the set of the image, which is the range. So now from the options you have here, you see that here now for A you have this set, you have for B this set, which is 1, 2, and 3. So this is the correct answer. B is the correct answer. So we can also correct the question number 3. An arc subtends an angle of 135 at the center of circle of radius 21 centimeter. Use pi, which is equal to 22/7. Find the length of the given arc and circle the letter that corresponds to the answer. Here you have 4 options for A, B, C, and D. To find the corresponding answer, to find the best answer, you have to calculate first. So, as solution, let us calculate the answer so that we will be able to choose the best answer among those 4. Yes. Now, first of all, let us identify the given data. We are given the angle of arc, which is equal to 135 degrees. Also, you have the radius, which is equal to 21 centimeter. You have also pi, which is equal to 22/7, right? Then, after having this one, we need to find what is missing. What is missing now is the length of the arc. We need to calculate the length, and to find this length, we will need to use the formula for finding the perimeter of the full circle, right? Remember that the perimeter for the full circle is equal to 2 pi radius. This is perimeter for the circle, the full circle, right? Since you have the arc, this arc is not the circle. So we have, consider this one as the circle. Now this is the radius. So we have, when we draw like this one will be 90 degrees. Let us assume that this one is equal to 135 degrees, this angle. So this is the arc. From here to here is the arc of 135 degrees. So we need to find this length of this arc. So this is 135 degrees among the 360 degrees. That's why to find the perimeter or the length of the arc is equal to the angle of subtension, which is 135 degrees divided by 360 degrees of the full circle, then times the radius, times 2 times the pi, which is 22/7, then times the radius, which is 21. So this 360 degrees can be simplified by 2 to have 180 degrees. This is 1. Also, this 180 degrees can be simplified by 21 to have, by 22 to have 11. This one will be 90 degrees, right? Then we can simplify this 21 and this is 7 to have 1 here, to have 3 here. Then this is 3 and this 90 degrees can be simplified to have 30 degrees here, to have 1 centimeter. So now this length of the arc will be equal to 135 times 11 times 1 centimeter divided by 30 degrees. Remember, here you have degrees. This degree here also can be simplified with this degree. Then 135 times 11 by using the calculator is equal to 1485. Then times the 1, which is this one now, centimeter, needs to divide by 30. So this one will be equal to 49.5 centimeter. From the options that we have here, you see that the length of the arc is 49.5 centimeter, which is option number B. Then the best answer, the correct answer, which is corresponding to B, is 49.5 centimeter. So thank you for watching this video, and remember to subscribe, like and share to your colleagues. See you in next videos.